Hey everybody, this is Larry. This is me doing the last day of the year, December Leetcode Daily Challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's problem. It's a medium today. Seems like if I could click on it, the harder part. Today's problem is maximum differences between node and ancestor. Yeah. Let me know what you think. Hit the like button, subscribe button, join me on Discord. Did I always say that? Man, I am repeating myself. I got stung by a jellyfish earlier today, so I'm like a little bit. It still hurts. I don't know how long it takes to like not hurt or whatever, but I mean not like hurt, but like it stings, which is kind of annoying. Anyway, today's problem is yeah, and yeah, I'm probably not gonna do a drone today, but I'll do one maybe tomorrow for the New Year's. Maybe that makes sense. I don't know. We'll see. Cause medium, we'll see. Anyway, today's problem is maximum differences between node and ancestor. So given the root of a binary tree, find the maximum v for which there exists different node A and B. The maximum A is an ancestor B. So okay. So if A is an ancestor B, we want to find the maximum value. In this case, 8 is 1, okay, 7, okay. Yeah, I mean, I think there are probably a couple of ways to do it, but the way that I would think about it is just pass down the min and the max and then just go through it that way. And then basically a depth first search recursion type thing. That's basically it, really. And because it's linear time, because it is depth first search, I don't really look at constraints because linear time is usually good enough. Though I did look at it afterwards, not gonna lie, but linear time, I knew that it was gonna be okay. So yeah, okay, so I think that's good enough for us to start going. And yeah, you have a node, and then maybe you have a min and a max. Yeah. And we can do a couple of things. The reason why min and max works, if you just keep track of min and max, is because as you go down the tree, you're only going to make like the maximum difference is only coming from either comparing yourself to the min or the max, right? So I think that's basically the reason why. And if we have both of them, because it's absolute difference, it should cover it. And because we're doing ancestors, another way of thinking about it is with its children or descendants. So going downwards is more natural, if you ask me. Okay. So then, yeah, so the thing is, so we'll return root of, there are a couple of ways we can do it. Yeah, let's do it this way. And then we want some sender values, which makes this make sense. I guess min will have the max. Here you have to be a little bit careful if you want to use absolute value for that reason. Because then now your infinity values will be a little bit bigger. So then here, I just say infinity and negative infinity, which are of course nonsensical values. I don't like using the full version of it because sometimes it auto promote and it screws things up. You can do it though. I mean, you just have to kind of have more in your mind, but that's why I do it the way that I do. And then yeah, and then now, so best is you go to the maximum difference, let's just say is 0, because that's just between a node and itself, I guess. Yeah, I mean, I don't know. It's just the value and we return best. And then here, of course, we compare best with the max of either best. So the current value minus the min, and this can be negative in the sense that this is infinity. But other than that, it should not be negative. So this should be good. And then the other one is similar idea. And then, of course, you take the max of the recursion of the version, which is you go node dot left. And then now the min becomes min of the min and node dot well. And then max of node dot well. We could probably, cache these values so that we don't do it multiple times, but we'll do it again to the right. And maybe if here, is there at least one node? Yep. Oh, no. Yeah, at least 2 nodes even. So yeah, so then here we just have to, I mean, you could add validation in a couple of places, but I'm going to add it here is the same. As long as you're consistent, you should be okay. So yeah, so let's run for the examples and see, and hopefully this looks good. And it does look good. So yeah, really don't have any edge cases that I can think of. I mean, in theory, you could do like a linked list type, like one-sided thing for complexity reasons. But as I said, this is going to be linear time and linear space if you count stack space. So I don't really imagine there's anything really weird, but I could be wrong. So let's give it a submit though, and see how that goes. Same problem a year ago, apparently. I forget about that. Yay, today's streak it's at 640. Let me take a snapshot for that silly Leetcode contest maybe. But yeah, like I said, this is linear time, linear space. I don't really have much to discuss here. Let me know what you think. Let me know if you struggle with anything of this. But again, last day of the year. Thanks for watching. Thanks for kind of just hanging out with me all the entire year. Even if it's your first day or your last day, I don't know. Yeah, come hang out, hit the like button, subscribe button, come hang out on Discord, and have a great New Year's Eve, whatever, and have a great whatever. Whatever. See you soon, and to good health, to good mental health, and see you later. Bye bye.